Well, it's beautiful. First, I don't know. Was the DC glass voltage?
Is assignment 2?
Yeah.
It is. I now I fully graded. Yeah. So if you check your grade now, you will.
It says I have the same grade I had last night, so I think I got 0 out of 5 on the first one.
Yeah, in the first question, I must grade it by myself. So I.
So you have graded.
It is graded now.
I swear I just looked at them.
Yeah, so I can really your grade. Yeah, all of the assignment to submissions are full grade. Try this.
No, it isn't. Last night I said I got 0 on the first one.
In the first question,
I got 0.
no.
I had 5 before the first.
Before the first question, you have 5. After the first question has 5 marks.
I know, but
so
I still have 5.
No. So I can remove it. I already check it after the lecture, but no.
Because like last night I had 5 before.
Yeah,
this morning it says 5.
This morning.
Yeah.
I just agreed it now.
I know. I just checked.
It was 5. I will check it again. But I don't think. No one.
No, I think I wrote a pretty good paragraph.
Yeah, no one. Okay.
I said that.
I still need to.
He said that.
The delay week.
I guess that's what we're talking
But I guess that message not.
So.
It's not a bad thing. It shows up.
Oh, no. I was just wondering.
I thought about like halfway down. We got the really sweet. Is that all one person? Yeah. Pretty much.
Okay, let's start. At first, hello everyone. Welcome to our lecture today. At first, I published assignment 3, and the deadline of this assignment will be next week, before the start of this lecture. Actually, this very simple assignment. It will be as an exercise about the automatic repeat request lecture. Okay, so you already have previous knowledge about the automatic repeat request, so you will answer around 6 multiple choice questions. So it's very simple to you. Okay, so the deadline will be in the next week. Also, regarding to lab 2, I agreed with Omid, your TA, to have your lab 2 in next week on Friday. Not on Monday. No.
In lecture.
In the lecture time. Okay. So I think that it will be on 15 October. Okay. So lab 2 will be on Friday, October 15 at AM in this room. Okay. Will be in this room. Okay. This will save our time in the lab. Okay, so your deadline to submit your pre-lab answers will be on Friday, October 15, before the start of your lecture, and you will have 1 week after this lecture to submit your report. Okay, is this clear for you? Okay, that's good. Let's now start our lecture, but before we start, I think that everyone here suffered from the down of Facebook, WhatsApp, and Instagram applications. You not suffered?
Yeah.
You were busy in work?
That and I really don't use it.
Yeah.
I message someone
Was that
yesterday
yesterday?
once in a while, that's it.
Yeah, I think it was 2 days ago.
Yeah.
I didn't even notice.
Yeah. That's good. Yeah. Okay, so actually what happened, millions of people around the world were unable to access to Facebook, WhatsApp, Instagram, all the platforms operated by Facebook. As you know, WhatsApp is operated by Facebook, and Instagram is operated by Facebook. Okay, so all the platforms operated by Facebook were down, and this down, I think, last around 5 to 6 hours. All of the servers were down for around 5 to 6 hours.
That's why I stuff in this.
And and not only the servers of these websites or these applications. The problem was also in the IoT system in this building. So they have automatic doors that open with scan your card, for example. This system was blocked. So engineers were unable to access to the data center rooms to troubleshoot this problem. So all of the systems operated over IP and Facebook were down.
They got hacked or was it some sort of?
The first investigations, no, not hack. Actually, what happened? Someone, we don't know him or her.
It's
Okay.
fine.
Till now, we don't know him or her. It changed the public IP addresses of all the servers operated by Facebook. So, if, for example, one of the public IP addresses of the Facebook server, for example, was this IP. For example, this public IP address for Facebook. Actually, what happened when you want to access to Facebook, you write facebook.com in English, and using the domain name server, DNS server, this domain name server is located at your internet service provider, okay, will translate this English URL domain name to IP address, 2 bits, okay? So we'll translate Facebook to this public IP address, okay? And this public IP address is shared with all the DNS servers around the world, okay? So if I receive request, I want to go to facebook.com, okay, I already have the translation of Facebook to this IP address. What happened? Someone changed this IP address to another hidden public IP address for all the servers. Each server has public IP address. Its public IP address has been changed, okay, and make this public IP address hidden. So when we look at the DNS server, we can translate the Facebook domain name to IP address. What happened? The domain name server will translate Facebook to the old public IP address registered in this domain name server. But this public IP address is now not for Facebook, so we can't reach to Facebook. This problem also extended to WhatsApp and Instagram, to the IoT, Internet of Things devices, automatic doors, automatic lights, something like that. All of systems that have public IP address has been changed to another IP, and this IP was hidden. Okay, and this was the problem. Do you think this one is hacker or someone inside Facebook? I also think that.
Some engineers should get fired.
This one, I believe that this one is someone who has, in the design of the network, we define some security policies. For example, you can have access to certain router, but you can't do a specific configuration. You can do certain configuration, certain specific configuration in this router, but the high level configurations on this router, something that related to security, something that related to make this router up or down, you are not allowed to do this. So when you access using your username or password in this router, you can have access, but you can't, not all of the configurations on this router, you can't do it. You are not permitted to do it. Okay, so if someone has the permission to change the public IP address of main server of Facebook, I believe that this one must have all the policies, all the security policies to do everything in this. Okay.
I don't know how true this is. I believe it came out yesterday or this morning, but someone said that they did it because that, like, the person who did it said, "Oh, I did it because a friend that committed suicide because of all the conspiracy theories they were reading on Facebook."
Actually, we will.
So I don't know how accurate that
Yeah,
is, but
all of these are first investigations, so not confirmed yet. But till now, the main reason of this accident was this problem. So let's wait and see what will happen in the next days. And from this, we must know that we must not make all of our life activities rely on or depend on internet only. As what will happen if the internet network all over the world has sudden accident, no internet all over the world? What will we do?
Crazy.
return to monkey.
The problem is most of the governmental activities, services, health, public services are provided now through internet. So this is not a good thing to do. As we live now, we have single point of failure. Single point of failure of this point, which is the internet, is failed. I think that most of our life activities will be off.
What kind of event could cause, like, I feel like our internet network is pretty, like, there's definitely places where you have outages in areas, but like, I feel like you need a pretty major event to have the entire network shut down. What would you?
I mean that if we all over the world, we don't have internet.
I know, like, what could cause that? Like, I feel like you
What
need, like,
would
some
cause
sort of,
this?
like,
Yeah,
major-
maybe many reasons. So maybe that nuclear or for example, something like that.
I think we have bigger problems.
So as what is internet? Internet are group of devices, servers connected all over the world through cables. Okay, optical fiber cables. For example, 30% of the internet cables worldwide are in Suez Canal.
Where?
Suez Canal. Yeah, in Egypt. Yeah, 30% of the internet connection.
But really like that we ever given.
As if you see this is the map, this is Europe, Asia, Africa, North America. This is the location of Suez Canal. Okay, so connect between Europe, Africa, India, China. So we have 30% only here. So what will happen if there is a problem in Suez Canal, for example, for this cables?
Is that the only tunnel we have? Like, because I know like North America connects across.
Actually, you can reach from Europe to India, for example, through this way. This is a map. Okay, so you have only two ways to have this way and to the optical fiber cable to move through Suez Canal.
There's actually a loop around Africa, or does it go like partially through it?
I think it's very difficult to make installations in the land. Yeah, so if I want to install optical fiber cable in the land, we must deploy it in the land. We will need to make holes in the ground. It will take lots of time. And in the sea, you just install the cables and make the protection and in the sea. Yeah. So this is the problem. So I think that they must be aware of this problem, and I believe that they already have some awareness about this problem. Okay.
Do you think networking will eventually move towards like satellite connection instead? Like I know it's more costly right now, but there's like Starlink and
Actually, communication through satellite, okay, is already technology that we can use now, but still have some problems in terms of the available data rate. Okay, the data rate provided through satellite communications, we can't compare it till now with data rates provided by optical fiber till now. Also, satellites, signals from satellites may be affected by some weather or atmospheric conditions. Okay, as at the end, we are transmitted radio waves to the ground, and radio waves are affected by rain, by fog, by some snow, by some atmospheric weather conditions. So we can use, yeah, I believe with you, I agree. Sorry, I agree with you that we can use satellite communications as backup, but we can't rely on satellite communications to be the main provider of the service. Okay, we use it in the areas that don't have any mean of communication network. For example, for oil companies in oceans and in seas, overseas, in factories in deserts, for example. In desert or in ocean, we don't have any communication network. The only way is to have connection from satellite. Okay. So we are forced now to use the satellite communication. Okay, but still satellite communications still have some major drawbacks that prevent this technology to be our main provider of the service. Okay, and in addition, it is also very expensive. Okay, so we discussed this problem as This was the major problem in communication network in these few days. So as communication network engineer now, you must be aware of this problem and what is the reason of this problem and how we can overcome it. This is the case of anyone asked you, yeah, you already registered the communication network course. Please explain to me what happened in Facebook and WhatsApp. So you must now be able to explain this. But again, these are first investigations, not confirmed yet. Okay, so returning back to our lecture, we discussed the automatic repeat request in our previous lecture. Can anyone summarize to me in 1 or 2 sentences why we need to use automatic repeat request protocol?
To ensure no errors
No, to ensure no errors. How?
by doing those 3 methods to make sure that we have our acknowledgements received.
Okay. Anything else?
Give time off to emotionally compromised engineers.
Okay.
Make sure there's not more congestion happening in the network.
Okay. So the main use of automatic repeat request is to make sure that our data are transmitted in a correct way. How? This protocol allows us to retransmit packets that have errors or missed in their way to the destination. So through using this protocol, the receiver will ask the transmitter to repeat transmitting the packets that have errors. So at the end of our communication, we are sure that all packets are received by the receiver in correct way, which means that all packets received at the end of this transmission will be correct and valid to be used, as in synchronous services such as web browsing and emails and so on. We have actually 3 types of automatic repeat request protocols. We have stop and wait, go back in, and selective repeat. Okay, so we started with the stop and wait automatic repeat request, and in stop and wait, from its name, the sender will send the packet and wait, send, stop, and wait for the acknowledgement from the receiver. And as we discussed in our previous lecture, that we have many cases. That the first case, the transmitter and the receiver, the transmitter sends the packet, 1, and the acknowledge was received within the timeout time. Okay, so this case of successful transmission between sender 1 and sender 2. Okay, so no errors here. Okay, in the second case, we have from the sender and from the receiver that the sender sent packet 1 to the receiver, and this when the receiver made processing over packet 1, receiver 1 discovered that packet 1 suffer from some errors. Okay, so receiver 1 will send non-acknowledgement. In this case, and this is within the timeout. In this case, the sender will know that, okay, so you already received packet 1, but due to some noises in the channel, the packet has errors, so we must fix this error by retransmitting this packet again. So transmitter 1 will retransmit bucket one again. Okay, and for sure we'll wait for acknowledgement for this bucket to confirm that this bucket is received in a successful way. Okay, this was our second case. Our third case, the transmitter sent bucket one, and due to any failure in the network, this bucket one is not received at the receiver. What will happen in this case? The transmitter will wait for the timeout. We call it time to live. Okay, of the bucket.
Sorry, time to live.
To live. Yeah. Okay. You understand it? Time to live. From its name, the time that this bucket remains online. After that, we consider it as dead bucket. Okay. So we have here timeout. If when the timeout is over, the transmitter didn't receive any acknowledgement about this bucket within the timeout, so the transmitter will retransmit this bucket again to the receiver and wait for acknowledgement. Okay. The fourth case, we have transmitter and we have a receiver, and the transmitter will send the bucket one to the receiver. The receiver will make processing over bucket one and will make sure that this bucket one is received in a correct way. It's correct, no errors. So receiver will reply to the transmitter with acknowledgement. But due to some failure in the network, sudden failure, transmitter didn't receive the acknowledgement. So the transmitter will wait for the timeout, okay, and will retransmit this bucket again. So transmitter will retransmit bucket one again to the receiver. As the receiver will process bucket one, and if this bucket one and will overwrite this bucket one over the previous processed bucket one. Okay, so this what will happen, and I think this cover all the scenarios that may happen in stop and wait transmission. Okay, so stop and wait is the simplest automatic repeat query protocol. Sender send packets in order. They received from high layers, so we want to confirm that. In stop and wait automatic repeat request protocol, the packets are sent in their order and will also be received in their order. So we will transmit packet one, receive acknowledgement. After that, we will receive packet two, receive acknowledgement. If packet two has any problem, we will continue to retransmit packet two until it is received in a correct way. After that, we will continue to transmit packet three. So all packets are received at the destination in a correct way, in order, in their order, 1, 2, 3, 4. Okay. So the sender sends a packet and waits for an acknowledgement. Okay. Receiver expect that the packet in their right order will be received and decode the packet. If no error is detected, the receiver will send acknowledgement. If an error is detected, the sender will send non-acknowledgement. Okay, so this is the basic idea of the stop and wait automatic repeat request, and this slide summarizes what we discussed in these examples, but here in updated version in stop and wait, instead of sending acknowledgement of packet one, for example, here we send the packet one and the receiver must send acknowledgement for bucket 1. In updated version, instead of sending acknowledgement of bucket 1, we update the acknowledgement to be request bucket 2. It's the same. Okay, so here bucket 1 is received in a correct way. So the receiver will reply to you, please send to me bucket 2. So you understand now, yeah, okay, I will send to you bucket 2. Okay, if bucket 2 is received in a correct way, the receiver will reply to you, please, I request bucket 3. Okay, and so on. Okay, so we can summarize the stop and wait automatic repeat request protocol in these two algorithms. As the sender, at first, the sender will label buckets by sequence number. As we know, each bucket must contain its sequence number that define its order in the buckets. As we have data, divide it to buckets, and each bucket must have sequence number. So we start by the initial sequence number, which is the first bucket, which is 0. Okay, we transmit the bucket with sequence number of 0 and wait for acknowledgement. Okay, if acknowledgement is received within the timeout with request number greater than the sequence number, which means that we send 0. What message do we expect from the receiver to send to sender if bucket 1 is received in a correct way? Again, we sent bucket 1 and bucket 0. Okay, we sent bucket 0, and this bucket was received at the destination in a correct way. The receiver will reply to the source with and we exchanged this acknowledgement of 0 with request 1. Okay, so the receiver will receive request 1, which is greater than the sequence number of the packet that already sent. So the receiver will set the request number to be the sequence number. So, and go to step 3. So now the sequence number is equal to 1. The transmitter will send the bucket 1 and wait for acknowledgement. If the sender received acknowledgement message within the timeout with request 2, which is greater than sequence number 1, the sender will change the sequence number of 1 to be equal to the request number, which is 2, and go to step 3. Return back to step 3, transmit bucket 2, and so on. Okay, as the receiver set initial value of the request number to 0, and it will receive the bucket. When an error-free bucket is received, okay, with sequence number equal to the initial request number, the receiver will accept this bucket and update the value of request number to be request number plus 1. So we'll send acknowledgement with request number 1 plus 0 with 1, which is 1. So send acknowledgement with request number 1 and go to step 2 again to wait for the second bucket coming from the cell. So the receiver will send request number 1, and where here sequence number was 0. Okay, so 1 greater than 0. So the sender will update the value of the sequence number to be 1 and transmit bucket 1 and wait for acknowledgement and so on. This is clear for you? Anyone has any question till now? Okay. Actually, we can summarize the delay that can happen in the stop and wait automatic repeat request in this time frame. As you can see here, we have TD, which is the bucket transmission time, And the packet transmission time is the time to transmit all the bits of the packet on the wireless communication channel. So as you can see, this is the first bit and this is the last bit of the packet one. So this time is the packet transmission time. It's the time to transmit all the bits from the sender to the wireless communication. Okay, and we have propagation delay. The propagation delay is the time that the last bit in the packet takes to reach to the destination. As you can see, the time. This is the last bit, and it would reach to the destination at this point. So this time is the propagation delay. And we have also acknowledgement time, and we have propagation time for the acknowledgement, and we have the time out, okay, and we have the error rate probability. We have probability that we have error. Actually, the throughput of the stop and wait automatic repeat request can be calculated through this equation. The derivation of this equation is uploaded to you in your Canvas. Okay, you can see the derivation for only knowledge how this equation came from. And if we want to calculate, for example, we have example here. We want to send packet of 10 kilobits with rate of 1 megabit per second. Okay, over a channel with 2 propagation delay equal to 100 milliseconds, and we have probability of error equal to 0. So all of our packets transmitted over our channel will be received in a correct way. And we want to calculate the throughput of using stop and wait automatic repeat request. So we can use this equation to calculate this throughput. So we have 1 minus probability of error, which is 0, it will be 1 divided by 1. T of S is the success time, which is the sum of all time delays in our transmission. So we have here only 2 propagation delays, which are equal 100 milliseconds, plus the transmission time. We want to transmit 10 kilobits over 1 megabit per second. Okay, so this will be the time the transmission delay time. So we will add this time with 1 millisecond and divide by 1. So we can calculate the throughput, and as you can see here in this example, we can transmit 9 packets per second, and each packet contains 10 kilo, so we can transmit 90 kilobit per second. Okay, so we have 1 megabit per second, and so using stop and wait, we can only transmit 90 kilobit per second. So the utilization of this link is approximately 10%. So you have 1 megabit per second, you can transmit 1 megabit per second, but you only transmit 90 kilobit per second. So the utilization is around less than 10% of the link. So stop and wait is underutilize our network resources. We can improve this protocol more. So I remember one of you told me that it's not logic to send the packet and wait for its acknowledgement, and after that send the packet and wait for the acknowledgement. This process consumes time. Consuming the time means reducing the data rate. Okay, this is the main rule that we have in communication network. Increasing time, reducing rate. Decreasing time will increase the rate. Okay, remember this. Till now, everything is clear. Okay, let's go to the second. we have go back in, where n is the congestion window, is the transmission window, is the number of packets that we can transmit before receiving an acknowledgement. Okay, so from its name, can anyone tell me what will happen in this technique?
We'll keep sending it until like realizes it has an error, and then we'll go back to where that error is and then start sending again.
Can you demonstrate it with an example? So if I have error in bucket 2, what will happen?
It'll keep going until it's received like the error.
So you received only bucket 1, and when you are processing bucket 2, you discover that bucket 2 has an error.
So you'll send that, but the sender will keep going. So the sender will go 3, 4, 5 until it gets that error from 2, and then it realizes it needs to hop back to 2.
So, okay, so I will send 1, 2 has error. So I will keep transmitting 3 and 4. Okay, I finish my window, transmit all the packets in the window. What will happen after that? I will retransmit that to 2, 3, and 4.
Yeah.
Okay. Daniel, what's your opinion? Agree with. Okay. So from its name, that's correct. Go back in. At first, at the start of our transmission, we define our congestion window, our transmission window. For example, if we have this transmitter and this is the receiver, and the transmitter, if we have the congestion window is equal 4. Okay, and assume that 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are our packets. So we set the sequence number of the packets 0, 1, 2, 3. Okay, this is n equal 4. After that, we 0, 1, 2, 3. Second window 0, 1, 2, 3. Third window. Okay. And 2, 3, 4, 5, 6, 7, 8, 9. 9, this is 9, this is 10, this is 11. Okay. These are our buckets. We have 12 buckets that we want to transmit, and we define our congestion window to be 4. So using the go back in, we will transmit 4 buckets without waiting to receive an acknowledgement. So we will send bucket 1, 2, 3, 4. Okay. So after sending the bucket 1, 2, 3, 4, we all expect to receive the acknowledgement of bucket 1. Okay. After that, we are expecting to receive acknowledgement of bucket 2. Okay. At first, when we receive the acknowledgement of bucket 1, so the sender and receiver are now confident that bucket 1 is transmitted in a correct way. So, and the sender will adjust its congestion window to be from bucket 1. So this bucket is already levered. Okay. So adjust our sliding window to start from bucket 1 to bucket 4. Okay. So at first our window was from 0. Then use another pen. Yeah. Okay. So This was our initial window from 0 to 3. Okay. The bucket 0 was acknowledged. So we received it in a correct way. So in bucket, in our sliding window, we'll adjust our window to be from bucket 1 to bucket 4. Okay? Is this clear to you? Okay. What if I make this 0, 1, 2, 3, and this is acknowledgement of 0. Okay. Okay. What if we have a problem? Okay, in receiving the acknowledgement of bucket 1. Okay, and for sure the sender will continue to transmit 0, 1, 2, 3. It will transmit again 0. Okay. Okay, this is the case. And while 0 is transmitted, we are expecting to receive the acknowledgement of 1. What if we have a problem in receiving the acknowledgement of 1? Okay, what will happen? The receiver, okay, will return back, the sender, sorry, will return back to bucket 1, okay, and to see what is its congestion window include. The congestion window include buckets 1, 2, 3, and 4. Okay, okay, and will retransmit bucket 2, 3, and 4. Clear? Or give another example? Okay, so okay, so here again, this is the first window, bucket 0, 1, 2, 3. 0, 1, 2, 3. Okay, this is our window n equal 4. Okay, so here at the receiver, at this time, we must acknowledge the first bucket, which is bucket 0. Okay, and on the same time, okay, the transmitter will start the second condition window to transmit bucket 0. Okay, and will transmit. We are waiting for acknowledgement 2. In acknowledgement 1, here, acknowledgement 1, and at the same time, the receiver will send back acknowledgement. I send the bucket 1 in the second condition window, and so on. And here we are expecting to receive acknowledgement 2. Okay, so now the receiver confirm it to the sender that bucket 0 is received. Okay, so we adjust our condition window to start from 1 to 4. Bucket 1 is acknowledged, so we will adjust our condition window to be from 2 to 5. Okay, so now we will detect that we have a problem in bucket 2. Okay, so the sender will return back to its current window. Our current window starts from bucket number 2. What is the end bucket of this condition window? 5. Okay, so the sender will retransmit again bucket 2, 3, 4, 5. All the buckets inside the window, starting from the bucket that has a problem to the end of our current window. So the transmitter will return back and start from the bucket that suffer from problem, okay, and to the end of our condition window. So we have bucket 2. We start from bucket 2 plus n, which is the size of condition window, minus 1. Okay, so from 2 plus 4 minus 1, so we will start from 2 to 5. We'll retransmit again. Okay, here we'll transmit again bucket 2, 3, 4, and 4. Okay, and select now to receive acknowledgement of bucket 2, and so on. This is from its name. Go back in. When we discover that we have error, okay, we have error in bucket 2, go back to bucket 2 and retransmit in buckets starting from 2. So 2, 3, 4, 5. This is the basic idea of go back in. Okay, and so for using this way, we also key in that all the buckets are received in their correct order. Okay, as you can see here, we have a problem in bucket 2. So we retransmit all the buckets starting from bucket 2. Bucket 2, 3, 4, 5. To confirm that we received at first bucket 0, then bucket 1. So we must receive bucket 2 before receiving the bucket 3. This is why we retransmit all the buckets after 2 again. Okay. Okay. Let's complete all the techniques of the automatic repeat request in our next lecture. But this is clear for you?
Yeah. So in that case, then you're retransmitting packets 2 through 5. You've already sent packet 3. If packet 3 is received twice at the sender, what happens?
Okay, so I already hear
The receiver, yeah.
as a receiver, yeah?
Yeah.
Okay, so the receiver in this case will overwrite the new bucket 3 over the previous received bucket 3. Okay?
It's smart enough to know that that's packet 3.
Yeah.
What?
Yeah, it's smart enough to know that that's packet
Yeah.
3.
You want to check your
Yeah.
I just don't think that, because I only submitted it last night, like 9 o'clock.